Today we're going to be looking at the sine rule. The sine rule we use for when we're trying to find a side or an angle for a non-right angle triangle. The two rules that I have below will be here to help us with regards to which one we're trying to find. If I'm trying to find an angle, I would like to be looking at these set of rules here. If I would be like to find a side, I'd be looking at these rules here. How we actually label the triangle, if there is no labeling done for you, you can choose how to label it. If there's labeling done for you, that will be a little bit more restrictive on what you can do. With the triangle we have here, as you can see, we've got the capital A, that identifies the angle. We've got capital B, that identifies that angle, and capital C, that identifies that angle. From there, we then flow to looking at our sides. So capital A for that angle, then that means the small a is our side. Capital B for that angle, that means that side opposite that angle will be side little b. And finally, for C, the capital C's angle is opposite this line where the little c is. And this is how you start to use your formula. We will be looking at the cosine rule in a different video, but you do need to be aware of what you need and the type of information you need as to whether you're going to use the sine rule or you're going to use the cosine rule to find a side or an angle of a non-right angle triangle. So with this rule, you need one side length and one angle opposite to that side length and another side or angle to be able to calculate this. We will do a couple of examples to see how this works. The other thing to be mindful of is when you're looking at calculating an obtuse or an acute angle in the triangles. We will get to some examples of acute and obtuse triangles later on in this video. Looking at our first example, we're asking you to find side C. Before you do any calculations for trigonometry, please make sure that your calculator is in degrees mode. Otherwise, you might end up with some incorrect answers. So let's start this process. The triangle has been labelled for us, so therefore I'm just going to tidy it up so I know what is what. So this is going to be side A, this is going to be side B, and side C has already been labelled. And I use those by looking at my angles capital A, capital B, and capital C, and they're all opposite those sides. So when looking at the rule, because I'm trying to find a side length, I'm going to use the second one as you saw on the first slide. However, you do not use all three parts of it. You only need to use two parts of the rule to be able to find the side length. Looking at the information I have, I've got angle B and I've got side B. So my side B is 7 and my angle B is 35. So it's 7 over sine 35. I'm trying to find out what side C is. However, then I've got angle C, which is 105. So as mentioned previously, you can only work with the information you have. So if I have been given angle B and side B, use that. Then because I've been given angle C, I'm only left with one variable that I need to find, which is side C. This is how you pick the information you have. Notice for angle A and side A, there is no information, so I cannot use it. Like what we did when we were doing trigonometry, you need to get C to be on its own. So sine 105 is on the other side and it's doing the dividing. So 7 divided by sine 35 gets multiplied by sine 105 because it moves to the other side, and that allows C to be on its own. On your calculator, you can do this all in one go, and it's probably best to, because then you do not have any inaccuracy going on because you're simplifying certain decimals. So 7 divided by sine 35 times by sine 105. So for this calculation, I get an answer of 11.78828, and I'm just going to round to 2 decimal places, so that would be 11.79 is equal to C. So the side length for C would be that measurement. Now if there were units, please put units. If it was centimetres, metres or kilometres, do not forget about that, and pay attention to what the question's asking you to do. If it's asking you to round to 2 decimal places, the nearest unit, whatever it might be, just be aware of that. In terms of working out, this first line would be enough here, and your answer would be enough there. Depending on what the question is asking you to do, always look at how many marks the question is worth. That will give you a really good idea of how much working out the marker is looking for. So now if we were asked to find out the angle, we have this next question where the triangle has not been labelled for you. So you can label it as you see fit. I'm going to label it like this: capital A, capital B and capital C. Once I've got my angles labelled with the capital letters, I can now do my little letters. So opposite capital C is my little c line, which is 17 centimetres. Opposite my big angle B is my side B over there, which there's no information. And then for angle A, which is the angle I'm trying to find where the theta is, my opposite side is 13, so that will be my little a. So I'll be using the first rule from on the first slide, where I've got sine A and now sine C at the top of my fraction, and then my little letters at the bottom, A and C. As I have no information for my B and my little b, I'm therefore not going to be using that at all. So once again, similar to finding a side length, you're only going to be using 2 parts of your rule for sine rule. So let's pop the information in that we have. So I've got sine A, and my A, capital A, is a theta. So I'll replace that, and the side for A is 13. Sine C is going to be sine 62 over my little c, which is 17. We now go through the motions of trying to get theta on its own. So I'm going to go sine theta is equal to sine 62 over 17 times by 13. Now theta is still not on its own. Like normal trigonometry, the opposite of sine is sine minus 1. Please be very mindful of how you're putting this onto your calculator. The brackets are important. However, once it's in the bracket, you can write it like this and BIMDAS will just follow naturally on your calculator. Close the bracket and then we'll be able to find out what theta is. So the answer to theta would be 42.4693. However, we'll round it to 2 decimal places, so it'd be 42.47 degrees because we're finding the angle. So don't forget that unit. Same as the last page, if I was looking for working out, you would be able to give me that as a minimum and then your answer as a minimum. As you can see in the picture, this angle is an acute angle. So we know that it's between 0 and 90 degrees. Often visually looking at it is probably best. Otherwise, this question might stipulate whether it is an obtuse angle or an acute angle. So now having a look at this example, I've already filled in some of the information as that part I've actually gone over a fair bit. But now what we're looking at is this is an obtuse angle. We can clearly see that it's larger than 90 degrees. Therefore, I'm going to be doing some extra calculations at the end of the question. So I'm looking at finding angle B. So I filled in the information thus far, and therefore I'm trying to get theta on its own. So same as the previous example, so it's going to be sine 18 divided by 3.9 times by 8.5, and that's all going to be in brackets because I need to get theta on its own, so it's going to be sine minus 1, and that's going to be equal to theta. Now the answer you're going to get for theta is actually going to be the acute angle size. So the answer for this theta would be 42.34 degrees. Now in order to find the obtuse angle for this, one extra step, 180 degrees, subtract 42.34 degrees, and therefore my obtuse angle for this would be 137.66 degrees. And that is your final answer. So when you're using the sine rule, look at the information you have. You need two sides and an angle, or two angles and a side, to be able to calculate what you need to calculate. And be mindful, if you're finding an angle, identify whether it's an acute or an obtuse angle. Hopefully this has helped you with the sine rule. Please do watch the other video on cosine rule, as you will see the difference in how the questions look as to whether you're going to be choosing the sine rule or the cosine rule.